1982, the engineers in the city of Paris faced a catastrophic structural crisis that threatened to swallow sections of the historic French capital into the earth. The construction of the massive subterranean transit tunnels for the area railway system was causing waterlogged sand and lime strata to shift rapidly, threatening to collapse the foundation of centuries-old monuments above the earth. Now, the highly specialized chemical engineering breakthrough that permanently solved this crisis, allowing engineers to permanently and chemically freeze liquid soil into solid stone before tunneling, was unlocked by the brilliant doctoral research of an elite geotechnical scientist born and raised in Anambra State, Nigeria. In today's story, we will explore the remarkable engineering connection of Dr. Henry Olisa, a pioneer whose brilliant soil-stabilizing science helped preserve the architectural heritage of France. Now, to trace this spectacular intentional connection, we have to look closely at the highly complex world of underground civil engineering, because the city of Paris is built over a massive, unstable geological labyrinth. For centuries, the earth beneath the French capital was systematically hollowed out by ancient limestones, quarries, subterranean aqueducts, and deep sand pockets. When the French government initiated the expansion of its ultra-high-speed underground transit networks in the early 1980s, they hit an absolute engineering wall. As heavy boring machines cut through the subterranean layers, they encountered zones of non-cohesive liquid-saturated alluvial soils. The moment these soils were disturbed, they would flow like mud into the excavation pits, creating massive underground voids that caused historic streets and multi-story stone pavements directly above to crack, tilt, and face imminent structural failure. Standard concrete injection methods were completely useless because the fine sand particles blocked the heavy cement particles from distributing evenly. It was during this high-stakes infrastructure emergency that the analytical genius of Dr. Henry Olisa completely re-engineered the field. Now, born in Nigeria, Olisa excelled in his academic studies, eventually traveling to Europe during the post-independence era to specialize in geotechnical engineering and soil mechanics at elite French institutes. Olisa focused on his doctoral research on a cutting-edge, highly volatile engineering technique known as chemical grouting. Instead of trying to force thick cement into the ground, what Olisa did was he analyzed how low viscosity liquid chemical polymers, specifically structured sodium silicate matrix combined with organic hardening reagents, behaved when injected under high pressure into microscopic spaces between sand grains. Now, this sounds mouthful, right? But that's just one part of the many things it takes for the structural masterpiece that we have around the world today. So now, inside the research laboratories of Paris, Olisa ran thousands of empirical fluids. He ran dynamic tests. He discovered that by manipulating the precise chemical ratio and temperature of the silicate solution, he could control the exact gelation time of the fluid to a single second. That meant that an engineer could inject a liquid compound into deep waterlogged sand, allow it to spread flawlessly like water, and then trigger an instantaneous chemical reaction that bound the sand particles together into an imperial load-bearing synthetic sandstone block. Now, that's a mouthful, right? But trust me, the story just began. Now, the mechanics of Olisa's formulas were an absolute triumph of material science. When the aerial tunnel construction team faced imminent collapse beneath densely populated Parisian districts, they applied these exact chemical soil-stabilization protocols. Specialized injection rigs pumped thousands of liters of the engineered silicate compound deep ahead of the tunneling shield, transforming the treacherous mud into a stable, dry rock vault within minutes. The boring machines sliced through the newly stabilized earth with absolute safety, completing the transit corridors without damaging a single historical moment on the surface. Now, the global significance of chemical soil stabilization is celebrated in every tunnel engineering from London to Tokyo today. It directly enabled the construction of deep-level subways, underwater tunnels, and massive skyscrapers in cities around the world. But while the European textbooks highlight the corporate construction syndicate, the foundational mathematical models and chemical formulas that made liquid soil engineering safe were developed with the direct contribution of a brilliant scientist from Nigeria. Now, Dr. Olisa's work completely shatters the myth that African scientists were merely consumers of Western technology. He stood at the absolute cutting edge of European material engineering, using his profound understanding of chemical and geology to solve an infrastructural crisis that had baffled top minds of France. His legacy remains built directly to the silent underground vaults of Paris, proving that Nigerian intellectual capital helped support the weight of modern world. The key takeaway here is that stories like this prove that the foundational materials and the science chemical formulas used to stabilize the soil beneath major global capitals were unlocked by the elite Nigerian scientists working at the highest level of international engineering. If you want to keep discovering spectacular and hidden ways Nigerian intellectual genius like Dr. Olisa has shaped the physical architecture of the wider world, share this video, leave a comment below, and follow along for more untold stories.